In this video, we are going to focus on a couple of example problems that apply IUPAC nomenclature to determine the names of example alkanes and or haloalkanes. In this video, we will not go through the basic fundamentals of IUPAC nomenclature, but instead we'll do an application. If you need to review your IUPAC nomenclature before proceeding to this video, definitely check out video number 310, where I provide an overview of nomenclature and go through the rules in detail. In this problem, we are tasked with providing the IUPAC name of the following molecule. This is very analogous to the type of question that you may run into on a quiz or a class exam. So, how do we begin? Thinking about our IUPAC nomenclature handout that we went through in the last video, we need to find the longest carbon chain as step one of the process of naming organic molecules. How do we find that longest carbon chain? Well, the longest carbon chain we would find by starting at some end of the molecule and mapping out the longest pathway that we can without having to backtrack or lift our pencil. So we have several end points here in the molecule. Looking through, everywhere there's an end of the line, that could be the start or end of the molecule. So we have 5 different possibilities. We want to sort out whatever combination of beginning and end will allow us to make the maximum carbon chain length. And as I look at this, the maximum carbon chain length I can find would correspond to following through like so. This gives us a grand total of 9 carbons in that longest carbon chain highlighted in pink, and I can find no longer way to map my path through the molecule that wouldn't require I lift up that pink highlighter at some point or backtrack to go back over some regions I've already been over. So this is our longest carbon chain. Now with that in place, the next step is that each carbon of that longest carbon chain is going to be identified by a numerical location. We can start numbering the carbon chain from either end, where number 1 could be at the left end here, or it could be at the right end or lower end here. The way that we decide which of those carbons is carbon number 1 of our pink parent chain there is we choose carbon number 1 based on which end is going to be closest to a branch. Now the branches are the groups that branch off of that parent chain. So the line or lines that come off of the parent chain. So like right here where I'm highlighting, this would be named and called a branch because we have an atom here that comes off of the pink parent chain. Same thing here, we have atoms that come off of the pink parent chain, so we call this a branch as well. And this over here, the chlorine atom, we would also describe as a branch. I'm going to highlight each of my 3 branches, here, here, and here, in green for emphasis. And again, the branch is anytime you see a line coming off of the parent chain was in pink, we refer to that as a branch. So taking a look at our branches here, we number the carbon chain in pink. That was our parent chain. Based on which end, here or here, would we arrive at a branch first. So here would be first position, second position, third position, there's a branch. If we start from this end, it'd be first position, second position, third position, fourth position is where there's a branch. And so therefore the correct place to start is over here. So I'm going to go ahead and call this number 1, 2, 3, 4, 5, 6, 7, 8, 9, numbering continuously through that pink highlighted chain there. Now with 9 carbons in that longest carbon chain, the parent name for this molecule is nonane. If we were to refer to that handout, and you should be familiar with parent names that correspond to 1 to 10 carbons. So from methane with 1 carbon to decane with 10 and anywhere in between, you should know that. So the parent name here is nonane. Parent name is going to be the last part of the name for the molecule. So we'll hang on to that information for now. And then transitioning onward, now that we have determined the parent name and we've determined how to number the parent chain, our next step in the workflow is to determine the names and locations of all of the so-called branches. That was everything we'd specified that comes off of the parent chain. So let's go ahead and take an attempt at that. So taking an attempt at that, exploring our branches that come off. At position number 6, we have a chlorine branch. So I'm just making some notes here that we're going to call that a 6-chloro group. We call it 6 because the parent chain at position number 6 of that red chain is where the chlorine comes off, so therefore we call it 6-chloro. The dash is there because anytime we have a number from a letter, we separate it via a dash. Now at position 3 over here, we have a methyl group because that's a 1-carbon branch. So we call it a 3-methyl, again separating numbers from letters using dashes. And then our challenge branch is this branch right here. In this branch, we could think of our parent chain as being a zigzag line, and then what's coming off of that, which I'll show in green here in my little sketch, is we have a line that goes to, if we make this a condensed structural formula, a carbon, and that carbon had 2 lines coming from it, so therefore there's a carbon here and a carbon here, and then filling the octet for all of those with hydrogens, as we do to interpret line angle formulas, gives us this group here. And if we compare this group to the chart from step 3 of our IUPAC Nomenclature handout, we would see that this is referred to as an isopropyl group. A propyl group has just a chain of 3 carbon atoms, where one end of the chain is attached as a branch to the parent. This one, the attachment point is the middle carbon, and that's why we call it an iso branch, is because the attachment point is there at the middle with a methyl group on each side of this particular carbon. That is where it actually links to the parent chain. So we call this an isopropyl group, and more specifically, it would be a 4-isopropyl group because it's coming off of the parent chain there, the parent chain in pink, at position number 4. So now that we have our 3 branches in order, our 4-isopropyl, our 3-methyl, and our 6-chloro, what we do to finish off the name of this molecule is we plug those all in as prefixes listed in alphabetical order. Listing these in alphabetical order, we have to contend with a chloro, C, methyl, M, and I for iso. Now, alphabetizing those, we can plug in that chloro comes first, so the full IUPAC name of this molecule would be 6-chloro, because C comes first in the alphabet amongst our 3 different branches. Then 4-isopropyl, and then finally 3-methyl. And all these YL suffixes that we're using, methyl, propyl, those tell us that these are branches, that they aren't part of the parent chain through the molecule, but instead they're branches that come off of it. And then nonane is our parent name with the A and E suffix there, designating to us that this is a molecule that's just carbon-carbon single bonds, and there's no double bonds or triple bonds in there. In a future video, we will describe how to name molecules have alkene or alkyne groups with carbon-carbon double bonds or carbon-carbon triple bond, respectively.